All right, so number 42. Yeah, you just did this problem, right? The data show the chest size and weight of the bears. Remember the bears? These problems. Find the regression equation, letting chest size be the independent variable. Then find the best predicted weight of a bear with a chest size of 45 inches. Use a 0.05 significance level. All right, so how do we do it? So you have the final exam notes. And it's talking about, what are the key words there? Yeah, good job. Regression equation. So if you look at the final exam notes, where does it say stuff about regression?
Number 19.
18, is it 19? Oh, yeah. Prediction, yeah, it's number 19. Linear regression t-test. If P is less than 0.5, then strong evidence linear, use that. If it's greater than 0.05, not strong evidence, but instead do that. Yeah, there it is. Number 19 talks about how you predict with linear regression. So let's go to the linear regression t-test. That's what we'll do. So, all right, so we put this data in L1, this data in L2, and then we do linear regression t-test. Let's do that. When we do linear regression t-test, you know how it works. The X list is L1, the Y list is L2. It's already in your calculator, I'm sure. Frequency is 1. And we always choose not equals, don't we? It's a not equals test. And then calculate. And so I'm getting a p-value that is 0.01. So what does that mean when you get a p-value that is 0.01? Yeah, that's less than 0.05. And so if we go to the notes, final exam notes here, it says if it's less than 0.05, then that's strong evidence of a linear correlation, linear relationship there. So use y equals a plus bx and plug in x to find y. So let's do that. So I'm going to use the equation y equals a plus bx. What is the a? How am I going to get a? It's telling you that right on the calculator, isn't it? I'm getting minus 246.44196. That's good enough. Plus, and then b, if I go down one, I'm getting 11.9799. And then x. That's my a and my b. You guys getting that okay? And now we're supposed to plug in the x value. What is the x?
45.
The 45, the bear's chest size. We're trying to say there's a connection between the bear's chest size and how much the bear weighs, right? Bigger chest, bear weighs more. Smaller chest, bear weighs less. So we're trying to take that chest size and plug it in for x. If you have a chest size, can you use that to predict how much the bear weighs? Well, yeah, you should, because our p-value is really low, which means there's a very linear connection here. So this should work. So plug that in. Minus 246 plus 44196. So just basically I'm not going to write it all out again. Just plug in right there the 45. Plug in the 45. Hit the buttons on your calculator. See what you get. I'm getting 292.65. Yeah, now a good question I'm asked sometimes during the exam, because I don't want this to confuse you, so I want to be really clear. Sometimes students they'll do a good job, they'll do all this great work just like that right there, and then they'll be nervous. They'll look over at the answers, and they'll go, oh, there's no decimals there. One of them is 293. But that's not the same as 292.65. It didn't say to round anywhere, so I better choose none of the above. No, don't do that. It's the 293, right? So you always round however the answers did, even if it doesn't say so. I want to make sure I'm clear. I'm not wanting to fool you on that. Right? Does that make sense? So just whatever they did on the answers, you round the same way. They're saying which one of those, did any of those round the same? Yeah, that rounds to 293. 293 pounds. So we grab 293 on that. That makes sense? So whatever, if all of them were rounded to one decimal place, then I would round my answer to one decimal place. I just follow the lead of whatever they're doing in the answers, even though it doesn't say round. I just do whatever the answers did, right? So don't want you to get fooled by something silly like that. Good on that? Makes sense? You remember that? Let's go to 43. What did we do on 43? That one was just on our test, or well, they all kind of look alike. Not that exact one, I guess. Anyway, 43. Regression line. So you know what we're going to do, right? Same thing. Put it in L1, L2. So L1, L2. Stick that in L1, L2, and then just do linear regression t-test. Find the A and the B. It should be easy. In L1 and L2, hit the linear regression t-test. And same kind of thing. You're going to do linear regression t-test. And you're going to choose again the not equals, huh? We always do the not equals. Go down to calculate. And I'm getting, so y equals a plus bx. I'm getting an a value that's 140.4, and b is minus 6.2. So which one of those is that? Is it C? Yeah, C it is. Easy, right? Piece of cake? What could be easier? That's fresh in your mind. Okay, so let's go down and talk about Benford's Law. There'll probably be a Benford's Law one on the final exam. Because you know I like Benford's Law. I think it's a valuable thing. So, do you remember how to do Benford's Law?
Yep.
So do the L1, the L2. Which general category is Benford's Law? Goodness of fit. You're seeing if the patterns of people's writing checks fits with the normal pattern of human behavior Benford has observed. Right? Benford says normal human behavior, we're so darn predictable that when we write numbers, 30.1% of the time the front number's a 1. 17.6% of the time the front number's a 2, the leading digit, etc. So you take a bunch of checks and you compare them, see how well they fit, goodness of fit, with the normal human behavior that Benford's Law has observed. And if it fits well, seems like it's legit. If it doesn't fit well, then they're doing something funny with those checks. It's not normal human behavior, it's fraud. Somebody's writing false checks. So, let's try that. So, now the trick on this one, what's the one thing that could get you? Well, it's probably more than one thing, but remember the one thing we talked about that it's easy to get confused is reversing L1 and L2? This is actually L2 here, and these are L1 there, aren't they? It's vice versa. How do you know? Well, if you look on the final exam notes, where is it? Goodness of fit. Observed values go in L1, and the calculated stuff has to go in L2. Observed in L1, expected, which come from calculation, in L2. So you got to be careful there. That order matters. So these L2, I'm going to calculate. These numbers calculated will go in L2. Okay, so what's L2 going to be then? L2 is going to be 0.301 times the total number of checks, 784. And the next one is 0.176 times the total number of checks, 784. And then 0.125 times the total number of checks, 784. And 0.097 times the total number of checks, 784, etc. Put those in L2. L1 is going to be the 0, 12, these numbers, 0, 73, these numbers right here. That's L1. Put them in L1 and L2, and then do goodness of fit for that. Okay, so you just type these, actually write down L2, put these right in L1. When you get that all done, go to goodness of fit. And if you need to do degrees of freedom because you're using a TI-84, degrees of freedom is always what? Number of categories minus 1. How many categories are up there?
9.
1 through 9. Huh? So 9 minus 1, the degrees of freedom is 8. All right, so then we do 8, and I'm getting a p-value. Oh, I just got like 0. Did you guys get that?
Yeah.
Right. So the p-value comes out 0. So what does that mean when the p-value is 0? I didn't even write out the HO. What is the HO on this one? And the H1. The HO, this is goodness fit, is that they fit, and H1 is do not fit. And you know how evidence goes. It's weak for the HO, strong for the H1. Okay, so we got a really low p-value, low as it can go. P is low. HO must go away. Bye-bye, HO. So we keep H1. We say they do not fit. There's strong evidence that the leading digits on these 784 checks do not fit the pattern of normal human behavior observed by Benford. So what does that mean about these checks? They're fraud. Somebody's doing non-normal stuff. They're writing bad checks. So there's sufficient evidence. Therefore, we conclude that the checks are not fraud. No. There's sufficient evidence. Therefore, we conclude the checks are definitely the result of fraud. C. So that's evidence admissible in a court of law. There it is. All right. On we go. We good with that one? Done that one so many times? 45. In studying the responses to a multiple choice test question, the following sample data were obtained. At the .05 students level, test the claim that the responses occur with the same frequency. So what's the key word there?
Same frequency.
Yeah, did you hear me emphasize it? Same frequency. They're basically saying, are those all the same? Are they coming out the same? Or close to the same? So this is another goodness of fit, isn't it? We're saying, how well do those numbers fit with all being the same? How close are they to all being the same? So, if you go back to goodness of fit on the final exam notes, it says for equal frequency, that's same frequency, take the total number of values and divide it by the number of categories. That'll be your L2. Let's go back and do that. So, that means these are going to be our L1 because they're observed. And L2, how are we going to figure out L2? Where for L2, the total of all those numbers is what? What do they all total up to be? 80. Is that what it is, 80? You've done this problem so many times, huh? 80, right? If you add all these numbers up, I guess it totals 80. And then if they're each the same, right? So this is a bunch of people who took multiple choice tests and all their responses put together. And we're wondering, were there the same number of A's, B's, C's, D's, and E's on the multiple choice test? Well, if they were the same, how many would there be of each one? Total of 80 answers, 5 different types. So take 80 and divide by 5, and you get 16. So each being 16. So if they were all the same, they would all be 16, wouldn't they? If they were all the same, they would all be 16. So we're going to say, how well does what we saw fit with all being 16? That's the question. How well does it fit with them all being the same number of A's, B's, C's, D's, and E's? So it's a chi-square goodness of fit. We put L1 and L2 into our calculator. Chi-square goodness of fit. The degrees of freedom, which is always number of categories minus 1. How many categories? 5 minus 1. So degrees of freedom is 4, right? There's A, B, C, D, E, 5 categories. 5 minus 1, 4. Degrees of freedom, hit the button. I'm getting a p-value that is 0.759. Oh, is it none of the above? Oh, so there it is. Good to have the actual answer for you on YouTube. 0.759. Is that what you guys got?
Yeah.
Yes.
Okay, there's the p-value. 0.759, so it's not even there. Which is not comforting on a test. All right, let's go on to 46. Stop me if you want to talk about it, but I'm assuming these are fairly fresh in your mind. But feel free to stop me. 46. The table below shows the age and favorite type of music of 668 randomly selected people. Rock, pop, and classical based upon their ages. use a 0.05 level of significance to test the claim that age and preferred music type are independent. Okay, I just noticed my age isn't even up there. I'm in my 50s. What is that? You can't even hear when you're at that age, right? So it doesn't matter what kind of music. No, I'm just joking. All right. So test the claim. So what do we? What kind of test is this one? All right. So so what kind of test is this one? Yeah, it says it right there. Independence. Test for independence. So so we do the test for independence. So that's the matrix thing, isn't it? So if you go to the notes, where is it? Right here. Test for independence. HO is their independent. H1's dependent. Now, if you want to add to this, earlier I gave you some information. You might want to add in. What does independent mean? If two things are independent of each other. All right. So independent is do not affect each other. Do not affect each other. All right. Dependent means they do affect each other. All right. So if that helps. So anyway, so test for independence. What are you supposed to do? Second matrix. Go to the matrix menu. Hit edit. Select the size. Put the matrix in there. Then stat test, chi-square test. Right? That's how we do test for independence. So let's go back and do that. Okay. So I'm going to go second matrix on my calculator, which is on the left side, right above the x to the -1 key. Go over a couple times to the edit menu and hit enter. And so then I'm going to put in the size. This is a 3 by 3 matrix. Hit enter after both of those. And you'll set up a 3 by 3 and then put in that matrix. And when you're all done, hit second and quit, which is right next to the second. It's above the mode key. And then we go to the chi-square test. Not the goodness of fit, but just the normal chi-square, right? Normal chi-square test. And calculate. I'm getting a p-value. That is 0.0115. There it is. Hey. Two more. 47. The paired data below consists of the costs of advertising in thousands of dollars and the number of products sold in thousands. Find the value of the linear correlation coefficient R. So that's pretty simple, right? Just throw your data in L1, L2, and this is L1, this is L2, and then just do linear regression t-test. Okay, when you do linear regression t-test, again, choose the not equals option. Always. Calculate, and then you got to go down a ways because the R is way down at the bottom. You'll get R is 0.7077, so it rounds to 708. There it is, answer D. R is the linear correlation coefficient. Let's go on to 48. Okay, number 48 then. So it's the last one. 0.05 students level. Looks funny. Results have been obtained. What happened to the copy there? Is it all messed up? Oh yeah, I must have copied it funny. Whatever, we'll just do the best we can. There's a bunch of results. Yeah, it looks like I didn't copy it well onto my thing. Anyway, you have it on your sheet, right? So we're trying to figure out, they want us to figure out if those are, what does it say we're testing for? Does it say ANOVA?
No. Because it's smaller than
It says, at the .025 students level, test the claim that the 4 brands have the same mean. So test at .025 significance. I'm making that kind of funny. That the 4 brands have the same mean. So these are different brands of something, some kind of different brands, and we're testing at the .025 significance level that the 4 brands have the same mean. Do those 4 brands all have the same mean? That's the test. What kind of test is that?
ANOVA.
Yeah, you're going to be able to recognize that. It won't be the last one, because like this thing's in order. But the real exam, the real final will not. It'll be all mixed up, so it could be anywhere. There'll be 29 questions. So one of them, one of the 29 will be an ANOVA question. How do you recognize it's ANOVA?
More than 2.
More than 2 groups, right? All we've learned to do is 2 groups at maximum, other than that last section. This is the last homework we did, chapter 12, ANOVA. More than 2 groups. So that's what you recognize. So more than 2 groups means ANOVA. So there'll be one of those on there. So, okay, so what do we do for ANOVA then? L1, L2, L3, L4. Put the data in L1, L2, L3, and L4. And then go find ANOVA in your test. And go L1, L2, L3, L4. It's as simple as that. So if you recognize it, it'll be cake. If you do L1, L2, L3, if I put all the data in, hit the ANOVA button, I'm getting a p-value 0.0028. You all getting that?
Yes.
Yeah.
0028. So there it is. It's an easy mistake to make though, huh?
D.
Yeah, it's D. It rounds to 003. Watch out. Easy mistake to make. And there we go. So there's ANOVA. You'll recognize it on the actual final. It won't be the last problem, but it'll be the one with more than 2 groups. Got to do ANOVA. It's how we do an ANOVA test. More than 2 groups. Or it's when we use an ANOVA test is when there's more than 2 groups.